Good morning, students. Students, this lesson is of class 6th for the subject of mathematics, which is covered on page number A3 in chapter Fundamental Concepts of Algebra of your textbook and is being submitted to you on 17th November 2020. Students, in this lesson, we will learn about the basic concepts and terms used in algebra. I hope everyone is ready for today's lesson. So, students, let us start. My first question is, what are expressions? I repeat, what do you understand by expression? Expression is a way of expressing the numbers in different form. I repeat, expression is a way of expressing the given numbers in different forms. So let's take an example. Children, we have three numbers, that is 7, 5, 8, and we have three operations, that is addition, subtraction, multiplication. Children, what we have? We have three numbers, that is 7, 5, and 8. And we have three operations that are addition, subtraction, and multiplication. Now, children, by using these three numbers and three operations, we have to make four different expressions. So children, here we go. We have four expressions, that is 7 plus 5 minus 8. Next one, 7 minus 5 plus 8. Third one, 7 multiply 5 plus 8. And the last one, 7 minus 5 multiply 8. Children, even you can think of many expressions. In this particular expressions, we have used only numbers. Students, can you see that in the first expression, we have used only numbers? Even in the second one also, we have used numbers. Third and fourth also. So children, if we are using only numbers, that expressions are called numerical expression. So all these four expressions are called numerical expressions. Children, why they are called numerical expressions? Because here we have used only numbers. Let us take one more example. Now, form three expressions with numbers 12, 6, 20 using only two operations, that is addition and division. How many numbers do we have here? 3, that is 12, 6, 20, and we have to use only two operations, that is plus and divide. So here we go. Let's see what three expression we have made. They are, the first one is 12 plus 6 divided by 20. Now second one, 12 divided by 20 plus 6. Third one, 20 divided by 12 plus 6. Now children, in these expression also, we have used only numbers. You can clearly see in this oval box that we have used only numbers. So what you will call these expressions are called numerical expressions. So I guess children, you are clear that what are numerical expressions? Okay, so let us move ahead. Now let us take one more example. Now children, this is very easy example. I guess everyone knows this answer. Now, what should come in this box so that our answer is 5? Now look carefully at this example. What should be in this box and added to 3 will give us 5? It's very simple. Your answer is 2 because 2 plus 3 is equal to 5. Children, here also we have used only numbers. That is 2 plus 3 equal to 5. Now children, here I don't know the value of box. So instead of this box, I can use x. So I can write x plus 2 is equal to 5. Find the value of x. The way we have done in this box. Like what should come in this box so that when it is added to 3 will give you 5. Similarly, x plus 2 is equal to 5. Find the value of x. I have used x in place of box. You can take any literal coefficient. You can use any alphabet. Even you can use x, you can use y, you can use a, whatever you want. So children, when we use x, y, z, these are called variables. What they are called? Variables. Just remember, whenever we use x, y, z, what they are called? They are called variables. Now, children, let us move on to the next example. That is, I have used a square, a pentagon, a circle, and they are added to 5, and your answer is 15. So, children, again in this example, instead of these figures, I can use alphabets, any alphabets. So let's see what I have used. So children, instead of these shapes, I have used X, Y, and Z. So I can say that X plus Y plus Z plus 5 is equal to 15. So here all the alphabets are called variable. They are called variables. So let's see what are variables. Students, variables means something that can vary, that is change. The value of variable is not fixed. Its value is not fixed at all. It can take different values. So what are variables? Variables are those whose values are not fixed and it can take different values. Children, let us understand this concept more clearly by taking the example of matchstick patterns. Now, look at the following patterns of letter L by using matchsticks. Now, children, look carefully. Now, can you see one L in the picture. Now in the next one, there are 2L. Now in the third picture, there are 3Ls. Okay, so let's see what we want to do in this L. Now students, in this first L, can you see how many matchsticks I have used? Let us count. Number 1, number 2. How many matchsticks do we need? 2. Now children, if I want to write 2L, how many matchsticks do I need? 1, 2, 3, 4. So to make 2L, how many matchsticks do I need? 4. Now children, let us see the next one. We have to write 3Ls. If we want to make 3Ls, how many matchsticks do we need? Let's count. 1, 2, 3, 4, 5, 6. So let's write these values in a proper way. So now children, we have written all these things in a box. Number of L formed. Children, you can see from the above picture that if we need 1L, how many matchsticks do we need? 2. Now look at the next 2Ls. If we want to write 2Ls, how many matchsticks do we need? 4 matchsticks. So I have written here 4. Now let us look at the last one. We have written 3Ls, and to write 3Ls, how many matchsticks do we need? We need X. So similarly, if we want to write 4 times L, then how many matchsticks do we need? 8. Next, for 5 Ls, we need 10 matchsticks. So children, can you see some pattern in this? Look carefully. For 1, we need 2. For 2, we need 4. For 3Ls, we need 6 matchsticks. For 4, we need 8. Can you figure it out that the number of matchsticks required is equal to double of L formed? You can see 1 twos are 2, 2 twos are 4, 3 twos are 6. So can you figure it out that we need matchsticks double of L formed? So if we need X number of L's, then the number of matchsticks will be equal to 2 multiply X. So how many matchsticks do we need? We need 2 multiply X or 2X. So children, you can see here that I have used variable. It is clearly there that if anything is unknown, we can take that as X. So here we can easily find the number of matchsticks if we know the number of L's. Okay, so here the value of X is not fixed. It can take any value. It can take 1, it can take 2, it can take 3, or anything. So remember, a variable is a number which does not have a fixed value. It keeps on changing its value. Now children, to understand this concept, let's look at the another pattern. Now let's have a pattern of letter E by using matchstick. Now let's have a look. Children, in this, the first one, E. Let us count the number of matchsticks we used in making 1E. Let's count. 1, 2, 3, 4, 5. How many matchsticks we need? 5. Now let's look at the number E. How many E's we need? We need 2 E's. So let's count number of matchsticks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many matchsticks do we need? We need 10 matchsticks. Let's look at the next one. That is 3 times E. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So students, in this, how many matchsticks do we need? We need 15 matchsticks. So let's write these values in a proper way, that is in tabular form. Now let's see. Now children, in making 1E, how many matchsticks do we need? 5. Now when we have written 2E, how many matchsticks we needed? That is 10. Now if we need 3E, we need 15. So now children, you can see that. Look at the pattern very carefully. Here, the number of matchsticks is equal to 5 times the number of E's formed. Easily you can see. 1 into 5, 5. 2 into 5, 10. 3 5s are 15. 4 5s are 20. So it means number of matchsticks required will be equal to 5 times number of E's formed. So children, if we want to find Y number of E's, means Y times E. So then how many matchsticks do we need? So we need 5 times Y, which becomes 5Y. So here Y is variable whose value is not fixed. So children, I guess you are clear with the concept of the variables. What are variables? Variables are the values which are not fixed and it keep on changing its value according to the question. Now children, let us discuss operations on variables. Variables are also called literals and unknown. What you can call variables are also called literals and unknown values. As variables are also numbers, a variable number may be added to or subtracted from a fixed number. In a simple language, you can add a number to a variable or you can subtract it from a variable also. Let's take an example. Now children, here I got 2 marks more than my friend's marks. I repeat again, I got 2 marks more than my friend's marks. Here, my friend's marks is not given. I don't know that how much marks my friend have got it. So let's take that value as X. So my friend's marks is equal to X. So according to the question, my marks will be X plus 2 because I got 2 marks more than my friend's marks. So my marks is equal to X plus 2. Now children, let us take the second example. Ria is 4 years younger than Raj. Find Ria's age. Now, children, let us read the question again. Ria is 4 years younger than Raj. Find Ria's age. So, here clearly, Raj's age is not given. So, we can consider Raj's age as Y. You can take any alphabet. Even you can take here X, A, S, T, whatever you want. So let us consider that Raj's age is equal to Y. So Ria's age will be equal to Y minus 4. Why? Because Ria is 4 years younger. Younger means you will subtract. So what is Ria's age? Y minus 4. So now, bache, the way we have added and subtracted, in the same way, we can multiply and divide a variable by a fixed number or a given variable. Now, children, let us move on to the another very important topic, that is algebraic expression. Now, children, before going further, let us discuss what is an algebraic expression. Expressions containing variables, literals, unknown, and constants are called algebraic expressions. I repeat again, expressions containing variables, that is x, y, z, and constant. Constants are fixed value like number 1, number 2, number 3, because it's never changed its value. 2 will remain 2 only. The face value of 3 is 3 only. So, what are constants? Constants are the fixed values which never change its value. So, algebraic expressions are the expressions in which we have variables as well as constants. So, let's have a look on few algebraic expressions. Number 1, x plus 5. Now, children, can you figure it out in this which one is variable and which one is constant? Yes, you are right. X is variable and 5 is constant because 5 is fixed. 5 will remain 5 only. Now let's look at the second one. Twice x minus y plus 12. Here variables are x and y and constant is 12. Next expression, 4x divided by 5. Next one, 3x minus 7 divided by 4. And last one, x plus y plus z. I guess you can tell me in this expression which one is the variable. All are variables, x, y, z. Now, children, I hope you are clear with the variables, constants, and algebraic expressions. Let us revise one more time. Variable is a value which is not fixed. It keep on changing its value according to the questions. Constants. Constants have a fixed value like number 2, number 3, number 4, number 11, because all the values are fixed. Now, algebraic expressions. Algebraic expressions are the combination of variable and constants. Whenever you see variable and constant, you will say that is your algebraic expression. Even if we have all the variables in an expression, that is also called algebraic expression. Now children, let us discuss few questions based on the above explanation. Question number 1. Name the variables and constant in the given expression. Children, in this question, you have to name the variables and constant. I guess there is no need to see the answer. Everyone knows the answer because variable is x and y while constant is 19. Let's check out the answer. Yes, variables are x and y and constant is 19. That is fixed value. Okay, now children, let us come to the next part, that is classification of algebraic expressions on the basis of terms. Now children, in algebraic expressions, when they are connected with positive and negative sign, they become terms. Now let me take the example of above question. Now in this question, we have x plus y plus 19. Can you see that how many terms are there? When when the numbers or variables are connected with positive or negative sign, they become terms. So there are three terms. First term, second term, third term. Let me repeat. First term, second term, third term. First term is x, second term is y, and third term is 19. Okay, children? So these are the terms. Now let us discuss the classification of the algebraic expressions on the basis of terms. The first one is monomial. Mono means one term. Children, if in an expression we have only one term, that expression is called monomial. No plus sign, no minus sign. It means there is only one term and that term is called monomial. Let's have a look on the examples. Your examples are 3x, only one term. Next, 4xy, only one term. Next, 2x upon 3, only one term. Children, here don't think that 3 and x will be considered as separate terms. No. Whenever you have plus sign or minus sign, then only it is considered as two terms. Here, 3 multiply x, it means only one term. Next one, 4 into x into y, 4xy, one term. Next, 2x divided by 3, one term. Now let's have a look on the next one. Binomial. Exactly two terms. Children, when in an algebraic expression we have two terms, like your terms are connected with positive sign or negative sign, then it becomes terms. And if there are only two terms, they are called binomial. What they are called? Binomial. Let's have a look. It is 2x plus 5. Next, x plus y, x, y, z minus 5. See children, here there are only two terms. Let's see. This is first term. This is your second term. So this is called binomial. Now in this, x is the first term, y is the second term. So binomial. In this whole xyz and minus 5, there are two terms. So they are called binomial. Now let us see the next one, that is trinomial. Tri means 3. Children, whenever we have 3 terms, they are called trinomials. So let us have a look on that. First one is x plus y plus 4, 2 plus 3x minus z. Let's see. In the first one, we have x, first term, y, second term, 4, third term. Now next one, 2, first term, 3x, second term, and z is your third term. So children, in these examples, we are having 3 terms. So they are called trinomial. Is it clear? What are monomial? 1 term. Binomial? 2 terms. Trinomial? 3 terms. Okay. So let's move on to the next topic. Now children, in algebraic expressions, sometimes we talk about coefficients. So now let us discuss what are coefficients. Let us take an example to understand this concept. Children, in 4xyz, first of all, tell me what is the name of this algebraic expression? Is it trinomial? Is it binomial? Or is it monomial? In this question, children, you are having only one term. How many terms do you have? Only one. That is 4xyz. So this is called monomial. What they are called? Monomial. Now let us see. The first thing is numerical coefficient. Let us discuss what is numerical coefficient. Now children, numerical coefficient of any term is the number itself. What is the numerical coefficient of any term? That is the number. What is the number of that term? So here it is 4. So what is the numerical coefficient? 4. Now let us discuss literal coefficient. Now children, you know that literal means variable. Very right. Literal means variable. So let's see how many variables are there. X, Y, Z. All 3 things are there. So what is the literal coefficient of this term? X, Y, Z. So now children, be careful that numerical coefficient is the number only and literal coefficient is the variable of that term. Okay. So now next is we have term 4xyz. Now children, we have to find the coefficient of yz. What we have to find out? Coefficient of yz. Let's see the term. Where is yz? So children, yz is here. So please cancel it out. Yz. What is left? What is left here? 4x. So what is the coefficient of yz? That is 4x. So the coefficient of yz is 4x. So whatever coefficient you have to find out, you have to cross that, and whatever is left, that will be your coefficient. Except that value, other things are your coefficient. Let us discuss the next one, that is coefficient of xz. You have to find the coefficient of xz. Now let us see what is the coefficient of xz. Let's hide xz in our question. This is x and this is your z. I have removed both the things, x and z. Except x and z, what is left? That is 4y. What is left? 4y. So what is the coefficient of yz? 4y. So children, be careful. Whatever coefficient you have to find out, except that whatever is left, you have to find the coefficient of that. Now, let's see. If I ask you, what is the coefficient of 4x? What is the coefficient of 4x in the term? So obviously you will tell the coefficient of 4x is yz, the reverse of the third part. Now, so we can say that the coefficient of any factor is the product of other factors which are left. Now next is like and unlike terms. Now children, like terms in an expression are those in which the literal coefficients are same. What are like terms? Like terms are those in which the literal coefficients are same. So let us see. For example, 4x plus y and minus 3xy. They are having same literal coefficient. You can see that xy here and here, they are same. So it means they are having like terms. One more example, 2x square z minus 5x square z and 7zx square are having same literal coefficients. That is x square z, x square z, even here also x square z. So they are called like terms. While terms having different literal coefficients are called unlike terms. For example, 3xy and 5y square z. Children, you can easily figure it out that here literal is xy and here it is y square z. So they are not same. Next example, 2x and 9y. Here the literal is x and in another one the literal is y. So again they are not same. So I hope you are clear with like and unlike terms. Like terms are those terms in which we are having same variables, same literal coefficients. Okay. Now let's move on to the polynomial. Now children, polynomial is an algebraic expression whose terms are power of a literal. It's very easy. Polynomial is just like an algebraic expressions. Only in polynomial we are having powers of literal. Like here the variables are x. So the power is x square. So it means this is a polynomial. Let's look at the second part. X cube plus y square plus z square minus 5. Again, this is an polynomial because here we are having variables and we have the powers of variable. What is the power of variable? X power 3, y power 2, z power 2. And if we want to find the degree of the polynomial, then we consider the highest power. Can you see, children, which is the highest power? Is it 3 or 2? Which power is highest? 3 or 2? Obviously, it's 3. So what is the degree of the polynomial? It's 3. Now let us discuss example 1 also. Here the power of x is 2 and here the power of x is 1. So which is the highest? 2 or 1? Obviously, the power of x square is more, that is 2. So the degree of the polynomial is 2. Now children, let us discuss the questions from your textbook. I have selected few questions from your textbook and now let us discuss the questions one by one. Now, question number 1. Write the statement symbolically. First one, the sum of 3 and a. You just have to do addition. What is the sum of 3 and a? Simple. 3 plus a. What is the answer? 3 plus a. Let us discuss the next one. Product of 11 and p. Product. Children, what is the meaning of product? Product means multiply. So your answer is 11 into p. Next one, sum of y and minus 7 divided by 11. Let us repeat, sum of y and minus 7. So it is y plus minus 7 divided by 11. Now next one, 7 subtracted from the product of 12 and t. 7 subtracted from the product of 12 and t. So it means first you have to find the product. Product of 12 and t means 12t. And then subtract. So your answer is 12t minus 7. So you can say that 7 is subtracted from 12t. Now children, let's have next expression. Now question number 2. Now children, can you see this is an expression and this is an algebraic expression? 1 plus 3x upon 4 minus 4y upon 3 plus xy. Children, can you tell me that how many terms are there? How many terms are there in this expression? 4. Let's see how. 1 is the first term. 3x upon 4 is the next term. 4y upon 3 is the next term. Mine plus x upon y. These are the 4 terms. Let me repeat. 1, 3x upon 4. Even you have to consider minus sign also. Minus 4y upon 3 and xy. So how many terms we are having? We are having 4 terms. And how many? And then can you name the terms? Yes, we have already named the terms. They are number 1, then 3x upon 4, minus 4y upon 3 and xy. Now next third part is find the coefficient of xy. Now children, in this question you have to find the coefficient of xy. Where is xy term? Where is the term? This, the last one. This is the term. Now, bache, what is the coefficient of xy? But there is nothing written here. So it means it is 1. So what is the coefficient of xy? That is 1. Okay, students? Coefficient of xy is 1. Let's see the next one. Now find the sum of coefficients of x and y. Now children, can you see what is the coefficient of x? Now this is the second term. What is the coefficient of x? That is 3 upon 4. Okay. And what is the coefficient of y? That is minus 4 upon 3. Let's see one more time. Here, the coefficient of x is 3 upon 4 and the coefficient of y is minus 4 upon 3y. Okay, students. Now, in the question, they have asked about the sum of the coefficients. So, let's see 3 upon 4 plus minus 4 upon 3. Now, we have to add them. And you already know that if there is a fraction, you have to take the LCM. What is the LCM of 4 and 3? 12. What is the LCM of 4 and 3? 12. Now to make this as 12, you have to multiply by 3. 3 threes are 9. Now to make this as 12, you have to multiply with 4. So it becomes 16. So 9 minus 16, which further is equal to minus 7 upon 2. Now children, let us discuss question number 3, that is write the numerical factor and literal factor. Students, I guess you are clear with the numerical and literal factor. Coefficient, numerical coefficient or literal coefficient. It's so simple that numerical coefficient is the number itself. Okay. And the literal factor or coefficient is the variable. It's so simple. Numerical factor is the number of the term and the literal factor is the variable only. So children, what is the numerical factor of this? That is minus 4 and the literal factor is xy. Let's see the next example, that is a square b. Now children, in this, what is the numerical factor? Again, no numerical factor in this. Here, there is no numerical factor, so it will be 1 only. And what is your literal factor? A square b. And there is nothing written here, so it is numerical factor is 1 and the literal factor is a square b. Fine. So now let's move on to the next question. Now question number 4. Find the coefficient of b square in the following questions. Now children, in this, let's see what we have to do. We have to find the coefficient of b square. Now let's see where is b square. Let's read the term first. It is 7a square b square. What is the term? 7a square b square. And we have to find the coefficient of b square. So what is the coefficient of b square? That is, what is? It is 7a square. Very right. Now children, we have to find the coefficient of b square. So it is 7a square. Except that factor, whatever is left, that becomes its coefficient. Okay children. Now let's come to the next second part, that is minus a square b. What is that? Minus ab square. And again you have to find the coefficient of b square. So now children, let's see what is the coefficient of b square. Just hide b square, except b square, whatever is left, that will be the coefficient. So what is the coefficient of b square? That is minus A. So, children, I hope you have understood today's lesson and you have understood all the terms used in this chapter, that is, variables, constant, numerical coefficient, algebraic expression, likes, like terms, unlike terms, polynomial. So, which will listen the video one more time, and after that you are required to complete the following questions in your mathematics register. So your homework is written here, and after that please complete all these questions in your mathematics register. Thank you so much.